All right, 8.5. Today we are looking at angles of elevation and angles of depression. So on this little diagram here, the angle of elevation and depression are always coming off of the horizontal, so it's kind of fuzzy, but this is a person standing here, and there's their line of sight. The angle of elevation, he's looking up to this other person that's up on the top here. So this is the angle of elevation. It's the angle that goes up from the line of sight, or from the horizontal, and angle of depression is the angle that goes down from the horizontal. So we have a few different examples to go through. So the main thing when you're doing these trig problems that involve application, the story problems, it's really important to draw and label a picture so that you know exactly what's going on. So the first one says, Maria's at the top of a cliff. She sees a seal in the water. The cliff is 40 feet above the water and the angle of depression is 52 degrees. What is the horizontal distance from the seal to the cliff? To the nearest foot. So it doesn't have to be a great drawing, but here's my cliff. Here's Maria. The cliff is 40 feet high. And here's my little seal. I don't know what kind of ears seals have. There's the seal. So the angle of depression, now remember when we look up here, the angle of depression is going from the horizontal downward. So from her, here's the horizontal, going down towards the seal. This is the angle of depression. It's a really common mistake for people to just always draw a triangle and mark it in the middle of the triangle. So this is where the angle of depression is going to be on the outside there. So rough sketch, but now I'm going to draw an actual triangle and we're going to use that. So here's my right angle. This is 40. This is what I want to find right here because it says what's the horizontal distance from the seal to the cliff. And this angle here I need to find. Now that's not 52 because the angle outside that triangle is 52. But this creates a 90-degree angle. So if I just do 90 minus 52, that tells me that this angle is 38 degrees. So now I can do my sine, cosine, or tangent. So I have opposite and adjacent, so I'm going to use tangent. And then I would multiply both sides by 40. And it says round to the nearest foot. So 40 times the tangent of 38, it gives me 31.25, so to the nearest foot would be 31 feet. All right, next example. At the circus, the person in the audience at ground level watches a high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground. So let's draw that so far. So here's my platform. Here's my acrobat. So the platform is 25 feet. The acrobat is 5'6". How far is the audience member from the base of the platform? So here's my audience member. So they're sitting in their little seat, all excited. And how far is the audience? So this is what we're trying to find. The angle of elevation from the audience member's line of sight to the top of the acrobat's head is 27 degrees. So angle of elevation from the horizontal going up. So that's why I labeled this one inside of the triangle there. So now let's see what I really have going on. So I have 27 degrees down here. This is what I want to find. How tall is this? So 5'6". Now 6 inches is a nice one to work with, but I could just convert this into feet because this is the same thing as 5.5 feet. Now I can because 6 inches is a half of a foot. So now I can just add those. 25 plus 5.5 would be 30.5 feet. If it wasn't a nice number like that, you might want to convert it all into inches and then work from there. But based on this is what we can use. So from here I have opposite and adjacent again, so I'm going to use tangent. The opposite is the 30.5. The adjacent is the x. So multiply both sides by x. And then divide by tangent of 27. So this didn't tell us what to round to on this problem. So I get 59.85, so let's call that 60 feet. So we're sitting 60 feet away from the Acrobat. All right, one more. So we have Vernon.
Sorry again for the quick announcement. We have the current leaders of the can drive, and right now, Mr. Onsted's class is in the lead with 75 cans. Miss Tucky and Miss Landy are tied for second with 12, and then Mr. Sologard's class is with 10 in third place. Don't forget to bring your cans, guys. It's going to interact, and the winner gets a pizza party, so have a good day.
All right, so we have Vernon is on the top of the deck. Sorry, I had to pause for an announcement there. I don't know if you guys could hear that or not. Vernon is on the top of the deck of a cruise ship and observes two dolphins that are following each other directly away from the ship in a straight line. So I've got a couple. I'm not even going to try to draw a dolphin. We're just going to draw the little dolphin thingy here. So here's my two dolphins. He is 154 meters above sea level. So I labeled that. This is my ocean down here. Angle of depression to the two dolphins are 35 and 36 degrees. Find the distance between the two dolphins. So we've got a little bit of a trickier problem we have to set up here. So first of all, angle of depression, here's the horizontal line of sight. It's going down from the horizontal. So I'm going to draw and try to connect here. One dolphin, two dolphins. So the first angle of depression, this one was 35 degrees, and the whole thing was 36 degrees. So what are we going to be able to find here? What we actually want to find is just this distance here, in between the two. So what I'm going to do is create two different right triangles here and solve both of those. So first triangle, so this is going to be this spot here. Let me use some colors to help us see this. So if I do this as my first triangle, I have 154 meters. This is a length that we're going to try to find here. And then what would this angle be? So outside of the triangle, it took 36 degrees outside of it. So that means inside that triangle would be 54 degrees here. And then the other triangle, if I use another color here, let me draw this one out. This is still 154. This is what we're going to find. But now I have this. So on here, if this is 35 degrees outside of that triangle, 90 minus 35 leaves me with 55 inside the triangle. So now on both of these, I'm going to set up little trig equations. So to find x here, I have opposite and adjacent again. Now, these three examples all use tangent. That doesn't necessarily mean they will always use tangent. Just be aware of that. So if I do 154 times the tangent of 54, that gives me 212 to the nearest. So this length along here is 212. That's what we just found. Now over here, on this triangle, I'm going to set up close to the same thing, only using 55 degrees now. So 154 times the tangent of 55 is what the whole distance is going to be. And that gives me 220. So this little spot right here in between the two dolphins would be that whole length minus this length. So if I do 220 minus 12, that leaves me with 8 meters apart for the dolphins. Okay, so you have one to try. Here's the problem that goes with it. First question is sketch and label a diagram. Second question, actually answer what the problem is looking for. And for your joke, what did one campfire say to the other? Let's go out one of these days. Okay, hope you have a great rest of your day and make sure you're kind to someone today.